Similar polygons. I don't need it. There we go. All right, what a similar polygon is it's basically the same shape, different size. Okay? And so the similarity symbol is like this. That's what similar is. Of course, we know what this is, right? Okay, and so now we can actually understand what congruent is. It has two parts. It has the similarity symbol, and it has the equal symbol. So congruent literally means similar and equal. We're not going to deal with similar and equal. We're just going to deal with similar. So basically, we're going to have a small shape and a big shape, and they're going to be the same shape but different size. We do that in real life when we build buildings. We have a little bitty rectangle on a piece of paper, and then they build a giant rectangle, right? That's how buildings work. And they're similar, but not the same. We don't have any definitions, really, but we are going to look at corresponding parts of similar polygons. So we're going to look at corresponding parts and how that works. So I'm going to draw some parts and some polygons, and we're going to look at them and see why they're similar. All right. I'm going to draw a little one and a big one, and I'll try to make them as similar as possible. By freehanding. All right. I got these two shapes. I'll call this AB, C, and I'll call this XY, Z. Okay. So if these are similar, if triangle ABC is similar to triangle XYZ, this is what that means. This means that angle A is congruent to angle X. It means angle B is congruent to angle Y. It means angle C is congruent to angle Z. This is just like our last chapter that we did like this when we did with congruent polygons. When we made a congruency statement, this was also true, right? So the next part is what's going to be different. Side AB over side XY is going to equal, see that's a ratio, is going to equal side BC over side what? YZ. And that's going to equal, and I mean equal, side, what side's left? AC. And AC is going to be XY. Okay? So instead of these sides being equal, their ratios are equal. Okay, so let's go into a direct example of this so we can see what that means by the ratios being equal. So I'm actually going to use the same kind of principle here, and I'm just going to label this up. I'm going to call this 2, I'm going to call this 3, and I'm going to call this 5. I'm going to call this 6, I'm going to call this 9, and I'm going to call this 15. Okay, let's look at the ratio between all these sides. And even if you can't figure out which side goes with which side, I will go with, well, the biggest side of both triangles are probably going to go together, right? Does that make sense? The medium side of each triangle is probably going to go together. And the short side is probably going to go together. If they are similar, these ratios will all equal each other. Let's see what those ratios equal. 5 over 15. What does that simplify into? 1/3? What about 3 over 9? What about 2 over 6? So they all equal 1/3. They all have to equal the same ratio or it doesn't work. This 1/3 has a name, and its name is scale factor. Have you ever heard of scale factor? Okay. Pretty much anytime you have a map or blueprints or you have a scale factor. And so what this means basically is that this side is 3 times bigger than this side. Is that what that means? So this triangle, the side lengths are 3 times bigger. So the scale factor is 1/3, or 1 over 3, or 1 to 3. Okay, that's basically it. That's basically the concept that we're going with. And so we're going to actually start looking at the 2 theorems that we need. One's easy and one's, well, not as easy. So let's look on page 378, 379. And let's look at these 2 theorems, 8.1 and 8.2. Go ahead and copy those down. And then I'll kind of go over them. Let's go that. That's on 378 and 379. And they deal with perimeter and area. Okay, as we're getting to this, there's several things we can tell from this shape. I have a few variables here that I need to figure out. I need to figure out x, y, and z. So x is just this side. Y would be the perimeter of this bigger shape. Z is going to be the area of this bigger shape. Okay, so we're going to start with the side. Okay, so I need to set up a ratio. I need to find the scale factor. So I'm going to start with this shape. 5 over what would be my ratio of the two sides? What do you think 5 goes with? Does it go with x or does it go with 20? Okay, and I'm going to go ahead and reduce this into a scale factor. And so the scale factor for this would be 1 over 4. Now that I have the scale factor, I can find everything I need to know. So 1/4, and I want to know what this side is. So the small side is 2, the big side is, the small shape is 2, and the big shape is, what do I do now? Cross multiply. And this is easy cross multiply because x times 1 is x. 4 times 2 is? Does that make sense that this would be 8? Just looking at it because it's a real thing. All right, what do you think the perimeter of this shape is? 5 plus 2 plus 5 plus 2, that's what, 14? Theorem 8.1 basically said that the perimeter, the ratios of the two perimeter is equal to the ratio of the two lines. So basically the ratio is the scale factor, right? I already determined the scale factor, it's 1/4. So to find the perimeter, which is y here, I just do this. 1/4 is my scale factor, and perimeter of the small shape, and see the small goes on with the small number, right? Perimeter of the big shape, well, I don't know what that is, so y. I bet you I could just add it together if I really wanted to, but I don't want to. I want to do it this way to make sure it works. But I'm betting that I just do 20 plus 20 and 8 plus 8, and that will get it for you. All right, let's see if this works. Cross multiply. I'm going to get what? Y equals, what is it? I want you to cross multiply. You should be able to tell me this. Y equals, I heard this, is that right? Okay, does everybody see how I did that? Area is the hard one. The area theorem, what are you supposed to do to your sides? You're supposed to square them, right? So here's what I do instead. I'm going to take this scale factor, and I'm going to square the scale factor. Okay, so basically your scale factor is 1/4. And I'm going to have the area factor. That's not what it's really called, but that's what I like to call it because it just makes a pattern. So, do we remember how to square a fraction? What you do with the parentheses is basically do 1 squared over 4 squared. So 1 squared is, and 4 squared is 16. This is my area factor. Again, we could probably just do it now that we've figured out the sign. The area of this first one is 5 times 2. That would be 10, right? So the area of the second one should be 20 times 8, which is 160. But we want to do it this way because they won't always give us all the information. So let's see how this works. Okay, so here's my area factor because it's squared. It's in squares. And then let's look at my, so the area of this one is 10. The small one's 10. And I don't know what the big one is. You don't see this at all. I don't know what the big one is. So I'm going to cross multiply and I get z equals what? 160. And that's what I set it up here is going to be, right? Okay, I did that real quick. We'll do some more sample problems on that. So that's the information. The most important thing to realize is area is squared. So you have to square it. I have an example here. I have a little square. Everybody see the square? What's the area of this square? 4, right? So the area of the bigger one, I can put 4 of these squares into this one, right? And so looking at this, 2 and 4, that's going to give me a scale factor of 1/2, right? But that's going to give me an area factor of 1 squared is 1, 2 squared is, which literally means you can put 4 squares in this bigger one. This bigger one has 4 times the area of the little one. Do we see how that sort of works? All right, so now we're going to do sample problems to help you on your way to getting this done. Turn to page 381, and we're going to look at 3. It says, find the scale factor, then list all pairs of congruent angles and write the ratios of the corresponding sides, links in a statement of proportionality. So it says find the scale factor. How do I find the scale factor? I'm just going to pick a number, and I'm not going to pick a number on this one that's a decimal because I don't want to. Decimals seem like they're harder to work with. So I'm going to pick 6. Does everybody see that? Okay, I can show you the shape here. You can zoom in or whatever. So I'm going to pick 6 because that's easier. What number do we think 6 goes with? Do we think it goes with 8? Okay, how I tell this is the big one goes with the big number. So 6.75 is the biggest. It should go with 9. 6 is the middle number, so it should go with the middle number, which is 8. So you guys are right. Scale factor is not 6 over 8. It is what? 3 over 4? Okay, that's my scale factor. Now we're going to write a, what does it say? Find the scale factor, then list all congruent angles. So let's look at this. Angle A, what do we think angle A is going to go with? Angle L. Then I'm going to do angle B, and that goes with, maybe, and angle C. That's going to go with angle N. And then I got to do all the ratios. So AB over what? That would be LM, right? And that is going to be equal to BC. Let's see what BC is going to be equal to. Is that going to be MN? And let's see what the next one is. AC. That's going to be what? LN? Okay. And I did this really quickly. I mainly want you to see where I got all this information from. Okay. You're only going to have to do one of these. So that's the information it wants. And let's see. Does it want me to do anything else? No, that's all it wants me to do. All right, moving on to the next sample problem. 5. 5. The polygons are similar. Find the value of x. Okay. And I'm just going to sketch this real quick, just so I don't have to. That's terrible. 20 and 12. Okay, so basically what I need to do is I need to find the scale factor between this shape and this shape. Okay, so it looking to me like maybe 21 goes with which? 14? Let's find that scale factor real quick. What is it? All right, I got a scale factor. Okay, so the 3 goes with this one, and the 2 goes with this one. I usually do the first to the second unless it tells me to do something different. Sometimes it says do the smaller shape first, so you've got to pay attention to the directions. It didn't tell me, so I did the first one, then the second one. So when I do the problem, I'm going to start with the first one. X, what shape does it go with? Which number? It goes with 20. And so we just cross multiply like in our warm-ups, right? So I believe this is going to be 3 times 20 is 60. 2 times x is, and then I just, okay, and I don't know why I did beside it. It's supposed to be up and down. I did it so it would fit on the screen is why. It's 30, so I have to do it right. Is that what you're saying? Okay, so it's 30. Does that make sense? If I write in 30 here, does it make sense? Okay. So that's how you do those. And then we're going to skip one, go down to 11. It says find the ratio and their perimeters. So I'm supposed to find the ratio and find the perimeter. Oh no, just find the ratio of their perimeters. I don't even have to find the perimeter. Just find the ratio of it. So here's the big shape, here's the little shape. They don't give me much to work with, but I just need to find the ratio of the perimeters. And so basically, I just need to find the scale factor, because that's the ratio of the perimeters, right? So I got 12, and what else do I got? 12 goes with 8, and then simplifying, you got your answer, right? What's my answer going to be? 2/3. Okay. Tomorrow, I'm going to give you the answer of 3/2. What happened? Why did we get 2/3 and the book got 3/2? Because the book doesn't tell you which order to do it in, and they did it in a different order that we did. Is it wrong? No, because the book didn't tell us which order to do it in. When I give you a test, I'm going to tell you which order to do it in, so you don't have this problem. Does that make sense? Okay. But what I do usually, even though the book didn't, I usually do the first shape over the second shape, unless it tells me different. And on the test, usually I say I do the small one first. And you'll get an example of that before we get there. All right, let's look at 13. This one wasn't very hard. Let's look at 13. All right, it says two polygons are similar. The perimeter of one polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other polygon. That should be easy, right? I have a ratio on number 13 of 2/3. And I'm supposed to find, they give me the small polygon, so I'm supposed to find the big polygon. Okay? But I need to know where to write the numbers. Where am I going to write the number for the small polygon? On top or on bottom? Where do you think the small polygon goes? It's going to go on top because the smaller number is on top. The bigger polygon is going to go on bottom because the bigger number is on bottom. Does that make sense? Big goes with big, small goes with small, right? And is this just like our warm-up at this point? Cross multiply. $144 divided by 2. Maybe I'll divide it correctly this time. What's that going to be? Is that going to be 72? And if it is, does that make sense? Does it make sense that the bigger polygon is 72? Make sure, because I'll have some people tell me that, the smaller polygon is 48 and the bigger polygon is 24. Would that make any sense? The bigger one has to be bigger than the smaller one, right? So pay attention to that. You'll get two of those. One's going to be smaller, one's going to be bigger. All right, we're moving on to the last thing that we're doing on this assignment. Number 19, area. Okay, and I'm going to let you kind of see if you, this is 3 foot, and this is 27 right here. 27 feet squared, and the bigger one is 6 foot here, and it wants to know what the area is. How do we set that up? First thing, always when comparing two shapes that aren't the same size, is let's find the scale factor. It says they're similar, so scale factor would be 3/6, or what would that be? Be 1 over 2. Okay, now I need the area factor. I need to switch it to square units instead of regular units. So to do that, I need to do what? 1 over 2 squared. Which is the same thing as 1 squared is 1, 2 squared is 4. Now I need to figure out which shape should go on top and which shape could go on bottom. This is a smaller shape, right? Smaller shape should be matched with smaller number. Bigger shape, and instead of question mark, I'll just use x, cross multiply, and we're done. Other than being the first day back from spring break, are we doing anything super hard? Except for remembering how to do math and how to do school, right? That's pretty much what our goal is today. So your assignment is I'll turn off the recording.